Another skill you'll need for this test is being able to write the equation of a wave when you are given data. So I got some more pendulum data, and we're going to take this data and write the equation of that wave. So even though I can't see it makes it wave, it does, and I can write this equation. So first, we need the midline. So the midline formula is you take the highest point, the lowest point, add them together, and divide by 2. You're taking the average. So I came over here and I found the biggest numbers. Now remember, with negatives, smaller negatives are bigger than bigger negatives. All right, the negative 19 is lower than the negative 7. So the negative 7 is actually my highest, and then it goes down, down, down to the negative 19, but then it starts going back up, negative 16. So negative 19 is the lowest. Then you can see negative 7. It's not exactly the same as the other highest, but it's pretty close. Real numbers are never perfect. And then back to the lowest, and you can see that we are going up and down and up and down. So first thing is the midline. I took the lowest plus the highest and divided it by 2, and that gave me my midline of negative 13.3. And again, you should always spot check. Is that negative 13 between negative 7 and negative 19? It sounds pretty reasonable. That should always sound reasonable. Now my amplitude, you got two options. You can take the highest minus the middle, or you could take the middle minus the lowest. Either way you want. You just got to be careful with the negatives here, because my highest is a negative 7.1 minus, it's always going to be subtract, the middle. And in this case, my middle also happens to be a negative, so it does have to be a negative 13.3. Those two negatives do make a positive. You do negative 7.1 plus 13.3, and it gives you an amplitude of 6.2. All right, so we got our midline and our amplitude. If we're going to write this equation, we next need the period. So a couple ways you can do that. If you have enough data, you can measure between the highest to the highest, or lowest to lowest. All right, because I had enough data, I just did that. So the distance from 0.6 to 1.8, you subtract those, and you get 1.2. If you didn't have enough data, you could just do the highest and the lowest. So 1.2 minus 0.6 is only 0.6, and then double it, which would give you 1.2 again. Now remember, if you're writing an equation, the period does not actually go in the function. So you have to, again, do this formula. Period is equal to 2 pi over b. The period is 1.2. We got that from our table. Now we have to solve for b. And it becomes b equals 2 pi over 1.2. That is what goes in our equation. Now, the next part's a little hard to visualize because we don't have a visual, but we need to start somewhere, okay? If we're going to pick either a cosine or a sine function, we have to know where we're going to start. So I decided the easiest would just be start at the highest point. That would give me a cosine function. So there you see my phase shift is x minus 0.6. That means we are starting at this point right here. That is the highest. So we have a positive cosine. My amplitude goes there. The b value goes right there. And then at the end is the midline. So there you have all the pieces. You didn't even have to look at the graph, but they're all there. So I want you to try that. Here is another data set you can take a look at. Pause the video there. This is the only practice problem for this one. And write the equation that models this data set.